He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
It's kind of cliche because everyone says it, but it is as close as you can come to leaving Earth without leaving Earth.
You can be going up a glacier with bare, brown, pink and glowing coloured rocks and ice hanging and really incredible scenery. And then a few days later you can be out on the plateau. You may be just absolute incredible monotony with nothing in view just day after day.
Just the grandiosity of the place and the size of the place, and just linking it back to the rest of the planet, that this place down at the bottom of the world that no one really thinks about will have a massive impact on us all.
Kia ora, nau mai haere mai. Hello and welcome to a new podcast series, Voice of the Sea Ice. I'm Claire Kincannon. The freezing and melting of a massive patch of the ocean around Antarctica is one of the biggest changes on the globe each year. When the sea ice forms, it more than doubles the size of this already giant continent. And this huge flux impacts the entire planet. For a long time, it seemed like sea ice was impervious to the warming of our climate and actually was growing in defiance of the models. But it appears that's now changing. In this series, we'll explore this type of ice, how it grows and melts, the life that lives on, in, and under it, what seems to be changing now, and what that means. Along the way, we'll meet some of the people doing science in Antarctica, this unreal place, and learn about the highs and lows of working here, as well as their hopes and fears for the future. First, though, we need to get acquainted with Antarctica. The icy continent, this frozen world, the Great White South, or simply the ice. Sensing a theme? There are different types of ice in Antarctica, and there is a lot of ice. This, dear listener, is like saying there are a lot of stars in the sky or grains of sand on the beach. It's a kind of a lot that our brains find really difficult to make sense of. But with the help of some epic voyages of the past and present, let's give it a red-hot go. 90 degrees south, the South Pole. Layer up because the wind is biting. The average temperature is about minus 60 degrees Celsius in winter and minus 28 in summer. Your breath freezes in your buff and tiny icicles form on your eyelashes. Sunrise and sunset here are incredible, but there's only one of each per year, so bad luck if there's a storm. You have to choose your time to visit carefully. For 6 months of the year, the sun never rises, though the aurora australis, the southern lights, can be pretty snazzy. In the other 6 months, under the light of the 24-hour sun, you would see that you're standing on a flat expanse of ice. This is the East Antarctic ice sheet. And below your feet is over 2 kilometers of ice sitting on the bedrock of the Antarctic continent, enough to cover Mount Tongariro. This ice has accumulated over millions of years of snowfall.
Antarctica is actually very dry and classified as a desert, but the key thing is that when it does snow, it stays. So the polar regions are very cold, and in our current climate, the snow sticks around and over a long time builds up into these colossal ice sheets, and colossal is the only word you can really use because they're kilometers thick and cover vast areas.
This is Dr. Daniel Price, a glaciologist at the University of Canterbury and chief scientist at the Christchurch company Kea Aerospace. If you can, now might be a good time to search for a map of Antarctica. Normally, it's just a smudgy bit down the bottom of the globe, but if you look at the map, you'll see there's quite a lot going on. It is, after all, the 5th largest continent on the planet. Bigger than Europe and smaller than South America. Most of it is covered in ice sheet. You can spin Antarctica around however you like, but the way most maps orientate it looks to me like a small sideways elephant on top of a giant lung. I know, it's bizarre, but it's stuck in my brain now and I can't help it. The elephant's trunk is the Antarctic Peninsula, reaching up towards South America. There's heaps of wildlife towards the end of the trunk, and even some patches of green. If you're about midway along, you would experience just 1 full day of sunlight and 1 full day of darkness per year. Where elephant ends and lung begins are the Transantarctic Mountains, tracing the line between West and East Antarctica.
The ice sheet is split into two, the West Antarctic ice sheet, which is kind of the little brother, and then the East Antarctic ice sheet, which is the big brother.
This eastern big brother has areas where the ice sheet is thicker than Aoraki Mount Cook is tall. Over 4 kilometres thick. This ice covers entire mountain ranges. The South Pole is on this East Antarctic ice sheet. No life, no green stuff. And in the time of Scott, Amundsen and Shackleton, what's termed the heroic age of Antarctic exploration in the early 20th century, there was nothing.
Wednesday, January 17. The Pole. Yes, but under very different circumstances from those expected.
This is an excerpt from Captain Robert Falcon Scott's diaries on the day in 1912 that he and his party reached the South Pole, to find that Roald Amundsen had already been and gone just over a month before.
We started at 7:30, none of us having slept much after the shock of our discovery. The wind is blowing hard. T minus 21 Fahrenheit. And there is that curious, damp, cold feeling in the air, which chills one to the bone in no time. Great God! This is an awful place, and terrible enough for us to have laboured to it without the reward of priority. Now for the run home, and a desperate struggle. I wonder if we can do it.
In 1958, when Sir Edmund Hillary and his team reached the pole in modified Massey Ferguson tractors, they weren't that impressed either.
It was an anticlimax, me actually reaching the pole. The big moment really was the last day we just drove on and on and on. I think we did about 60 miles or something. Even I was having some doubts about our navigation because we had to find the pole, you see, and sort of if we didn't find it, it was going to be uncomfortable. But I remember then we saw something sort of just that was different. We got out the old binoculars and it was a flag, and actually it was a flag that the people at the American base had driven out and had planted a line of flags. It was an enormous feeling of relief as far as I was concerned.
At that point, Pete got on the blower. He'd been in contact with the pole at that stage, I think, and said that we felt we were within about 9 miles or 10 miles of it, and the bloke said, well, where are you? And Peter, who's got a bit of a sense of humour, said, we're due north.
Classic Kiwi humour. Because when you're at the South Pole, everything is due north. But actually, Hillary wasn't supposed to show up at the pole at all. The plan was that the New Zealand team, led by Hillary, would support Dr. Vivian Fuchs' Transantarctic expedition, the first overland crossing of the entire Antarctic continent. They were supposed to lay out some supply depots for Fuchs to use on the leg of the journey from the South Pole to Ross Island. But I guess after laying the last depot on the ice sheet, Hillary got so close he couldn't help just popping by. You know, they were only 855 kilometres from the pole at that point. Unsurprisingly, reports are that Fuchs wasn't totally stoked on this at the time. This Transantarctic expedition in 1957 and 58 coincided with a year dedicated to scientific exploration called the International Geophysical Year. Leading up to this, to support both the scientific efforts and the expedition, New Zealand established a base on an island off the Antarctic continent called Ross Island. It's the southernmost piece of land in Antarctica accessible by ship, and here you get about 4 months full sunlight, 4 months full darkness. It was officially opened in January 1957 and named Scott Base. Here's Sir Edmund Hillary again about the early stages.
We were living in tents and dragging all the stuff onto the actual site and working on the site. And we always had this constant worry as to whether or not the weather would break and we get a blizzard. I mean, we just had to get the stuff off the ship and get the building going and get the buildings up. And really the good moment was when we got that first building up, wasn't it? Yeah. We got it up and tied it down, and then we knew that whatever happened, we could stow safe stuff away and that we had good shelter.
Since that moment, New Zealand has had a continuous presence in Antarctica. Summer or winter, Scott Base is always manned. The US were also involved in the International Geophysical Year, and in the mid-1950s they established 2 Antarctic bases, one also on Ross Island, close to Scott Base, called McMurdo Station, and another right by the South Pole. Hence why Hillary and the team were spotting flags. These marked the airstrip for the newly established Amundsen Scott South Pole Station. Still today, little coloured flags are used to mark safe and unsafe routes in Antarctica. So in 2025, standing on the sea ice at the geographic South Pole, you would see a small pole marker with a semicircle of national flags of the signatories to the Antarctic Treaty. But glance around you, and there's a lot more going on. You'll see heaps of those little flags, red, green and black, marking different routes. You'll see the South Pole Station building, where people live and work, up to 150 in the summertime. Then there's a runway where planes land. There's a jumble of containers and smaller buildings for storage. Then there are telescopes built to view the oldest light in the universe, and a neutrino detector buried deep beneath the ice, designed to detect particles from space. So a lot has changed since Scott's time, but also the ambition of some of these science projects and the wild background logistics in this harsh environment needed to get the science going kind of matched that heroic exploration vibe for me. Daniel's been part of one of these crazy expeditions, not to the South Pole, but to a place on the Ross Ice Shelf, which is the next step in our getting to know Antarctica journey, and the second type of ice I want to introduce you to.
All this ice of the ice sheet is up on the land, and as it accumulates mass and gets absolutely massive, under gravity it flows towards the ocean. And as it flows towards the ocean and meets the ocean, it starts to float, and this is where you get your ice shelves.
Instead of kilometres thick, ice shelves are generally hundreds of metres thick. So even though it's floating on water, it's still pretty darn solid feeling. There are 15 major ice shelves in Antarctica and many smaller ones. The Ross Ice Shelf is the biggest.
It's about the size of France and completely flat and completely white, and there is absolutely nothing to see.
Daniel speaks from experience here. Scott and his team used ponies, dogs and man-hauled sleds to cross the Ross Ice Shelf. Hillary's crew used dog sleds and the modified tractors. Today, planes to and from Otautahi Christchurch and other parts of Antarctica take off and land on airfields and skiways made on the ice shelf. But if you need to do science somewhere away from a base, if you need to set up a big camp on the ice shelf to bring in heavy-duty equipment and supplies, stuff you couldn't fly in, well, then you would need to cross it in specialised vehicles. Seems easy enough. The ice is hundreds of metres thick and mostly dead flat. Or at least it looks that way. Right up until the point a thin crust of snow beneath you breaks away and you tumble down into a pitch-dark icy canyon. You've met a crevasse.
It's sort of the interaction of ice that's moving at different speeds that creates these crevasses. You can kind of imagine putting the two palms of your hands on top of a big block of 1 kg cheese and pushing them in the opposite directions, and you'd get sort of cracking down the middle perhaps. That's what we're kind of talking about with the crevassing. And a lot of it is hidden.
Because different parts of the ice shelf are moving at different speeds, you get these zones that are rich in crevasses. You still got that map open in a tab somewhere? We're now north of the South Pole. Joking, never gets old. If we go back to the classic sideways elephant on lung map, we're now hanging out in the space between the elephant's back legs and the left-hand side of the lung. I say lung, others say East Antarctic ice sheet. Take your pick. You might see a faint outline traced on the map. Maybe a different colour, maybe a thinner line. Like a border, but clearly not quite land. This is the Ross Ice Shelf. Floating ice that's so big and thick and permanent feeling that it's like land, but it's not. Back in Scott's day, they called it the Great Ice Barrier because it blocked them from sailing further south. And at the bottom right of the Ross Ice Shelf, there is the little speck of Ross Island. Small on a continental map, large in New Zealand hearts. This is where you find Scott Base. And it's this area of Antarctica, around Ross Island, that we'll be hanging out in for most of this series. Quite close to Scott Base, a portion of the ice shelf is getting squashed against Ross Island, which slows it down. In the middle of the ice shelf, there's no such friction, and the ice is moving faster.
So out there it's moving at a metre a day, and in here it's half a metre or less. So it's just that velocity differential that causes the ice to just start shredding apart. And then, so running down the Transantarctic mountains here, you have what are called outlet glaciers, where that massive East Antarctic ice sheet is flowing down into the ocean through the mountain valleys. And where that comes out will also cause shear zones on the margins of those glaciers. So they're all over the place.
And these are not just little cracks in the ice. They can be 10 to 15 metres wide. But they're covered by snow, which forms a bridge on the top, making them hard to see until you break through.
And that's where we have to look to technology to help us out, to find out where the crevasses are, to make sure that one, we try to avoid them, and two, if we have to cross them, we want to make sure they're safe to cross. Back in the day, the only technology was ignorance, really, and there are some incredible photos of Hillary and those fellas getting stuck over these crevasses.
Incredible photos and amazing yarns. This is from the same recording as before, where Hillary and some of the team speak to RNZ at a 20th anniversary reunion.
Frequently we would drive into crevasse areas and not see anything at all. I can always remember one occasion when Derek Wright was with us, and this was the first time that Derek had actually taken the lead tractor. There was sort of a gentle rise ahead of us, but the sun was shining, it was very cold, but it was rather beautiful really. And Derek said to me, are there any crevasse areas ahead? And I said, no, it looks absolutely perfect to me. Well, we only went about a mile, and we all came to a grinding halt, and Derek had broken through the top of a really beauty, actually. And he was really mad at me, actually. He said, you said there weren't any crevasses up here.
There are other stories too. They pitched a tent over a crevasse one night. They lost dogs and equipment down one. But kind of astonishingly, nobody was killed. So yeah, they were quite lucky. You'll not be surprised that these days things are done a bit differently.
Today we can look to space as a first stop to help us. There are some pretty cool satellite technologies that are out there now. These are called active microwave radar satellites, and they essentially fire a chunk of energy at the Earth's surface, and it hits the surface, interacts with it, and comes back, all at the speed of light. And these images can be processed into something that the human eye can understand, and it reveals, like an X-ray, the crevasses hidden below the surface, which is an incredibly useful tool for us, which allows us to sort of circumvent crevasse fields, or if we have to go through them, find the best route to go through them.
But it's not enough to draw a line on this X-ray image of the crevasses and kind of hope that it's all right. You've got to check it on the ground too, using another radar.
You can kind of think of this as a minesweeper on the front of the vehicle that's looking down in real time, and we have a screen in the vehicle, so someone's driving and someone's watching the screen, and in real time it's revealing in front of us if crevasses are coming up. And we use that with the satellite to get a really good idea or situational awareness of what's happening around us. And day to day it comes down to assessing individual crevasses as we move through crevasse fields to make a call as to whether we can keep going.
Daniel was involved in finding a safe route for an ambitious science project that aims to drill through the ice shelf and then down into the seafloor below. But at a spot that's a 1,300 kilometre drive from Scott Base. And look, it's Daniel's way, but this is all a bit low-key understated here. It's not until you dig into the details that you realise how crazy what he's talking about actually is.
It can be a pretty stressful time moving across these crevasse fields. We Sometimes you're encountering a crevasse every 50 meters or so for, days and days. And we work sort of on a 1-to-1 ratio. So crossing a crevasse is deemed safe if the width of the crevasse is equal to the depth that it's buried. So you have these kind of canyons, these crevasses, these chasms underneath you, say one's 10 meters wide. The snow bridge on top that's filled it in needs to be 10 meters as well, and then it's permitted safe to cross. And we can assess that using the radar from in the vehicle. So we're constantly assessing in real time as we move towards these crevasses. We get a bit of notice because the radar's on an extended boom in front of the vehicle, about 8 meters ahead of us. And so we have a bit of time to process this. And as you get used to doing it, you can kind of make a call on the move as to whether it's safe or not. And a lot of them are well buried, so they don't even come near that criteria. And then occasionally we'll encounter some that are a little closer, and we'll have to stop and survey them multiple times to understand what's going on, and sometimes have to shift the planned route to circumvent the big gap beneath us.
Part of their journey goes through a particularly intense crevasse area, but this is along the South Polar Highway, the vehicle route to the South Pole Station, which the US team maintains. And they deal with crevasses in the typical American fashion, with explosives.
They go into what we call the shear zone, referring to the shearing through the ice, and use explosives to blow up the top of the crevasses and then fill in the crevasses with snow so that the vehicle traverses can safely cross over them, because it would be too dangerous to try and drive across that particular region because the crevasses are too dangerous.
Once Daniel and his team turn off this highway and they're surveying for the crevasses, they're moving at just 5 or 6 kilometers per hour. So they have time to stop if the radar picks up something ahead, which means their journey is very long and very slow. The first time was the budget trip, says Daniel.
So that first year was kind of a recce trip doing that route proving, and we only took 2 vehicles, a small piston pulley 100, which is about 3.5 meter long sort of machine that my colleague and I lived in for the entire time. So we're driving up front all day, and then like truck drivers would sleep in the back. That was pretty close quarters. Luckily we got along very well. And then the vehicle behind us was sort of the logistical support and safety vehicle in case something happened to us out in front. And that's all we had. And we had a sat phone and sort of MRE, boil in a bag food.
And tunes and podcasts, because the chat runs out pretty quick. Since this first route finding, Daniel has done the traverse out to the site a few times, which, is really putting your money where your mouth is, or your life in the hands of your science. And though they scouted the route, remember, the ice shelf is always moving, which means the crevasses can change and need to be rechecked and flagged each time. So the drive, at an average of 10 kilometres per hour, takes about 2 weeks. And then they'll set up a science camp or test equipment before driving back, a total of about 60 days.
Which can take a bit of a mental toll because there's just so little mental stimulation visually. It's a long time to be out there.
He describes the more recent traverses as bougier. There's a separate vehicle for them to sleep in, fancier food, and even, last year, Starlink internet access as they travelled. But the scenery stays the same.
Flat and white to the horizon is kind of the only way to explain it, because it literally is what it is. So you kind of leave Scott Base, you head south, there's a bit of back and forth as soon as you leave, and then you do a right-hand turn, and then it's 800 kilometers in a straight line down what's called the South Pole Road. And as you head down the South Pole Road, the mountains out to your right suddenly disappear below the horizon, and then for a couple of days you have absolutely nothing to see. And then as you move over to the eastern side of the Ross Ice Shelf, there's absolutely nothing there either. So it's there's not a huge amount going on for a long time.
What happens to your brain in that situation?
Everything slows down, I think. It is kind of difficult to interpret when you're in it. But there's definitely a slowing down of the mind because you don't have stimulation. And I guess it's kind of like muscles. If you don't use them, they kind of, parts of the mind start to slow down and shut off. So when you come back to base or back to New Zealand, it's quite exhausting, really, to start interacting with people, seeing colours, and just the mind is a little overwhelmed for a while until it readjusts to the normalcy of life.
Going to Antarctica is the closest thing we have, at the moment, to living on another planet. And look, When you can fly to the South Pole or drive there along the South Polar Highway, it's not got the same pushing the boundaries feel about it. But boundaries are still being pushed in terms of some of the crazy engineering and logistical feats to enable some of these science projects. And while there are better health and safety guidelines and technology to help, the dangers of the harsh environment remain the same, as does the reliance on the people around you.
And especially when you move away from the bases into what we call the deep field, when you're in the middle of nowhere and completely reliant upon the people you're with and the equipment that you have. It's a pretty humbling place to be.
Both Scott and Amundsen crossed the Ross Ice Shelf to get to the South Pole, via different routes. Amundsen made it back, but it became Scott and his two remaining team members, Wilson and Bowers' final resting place. Here's Sir Charles Wright, one of the team that found Scott's last camp, talking about what will happen to their bodies.
They will be frozen. They will be imperishable and either come out on the face of the barrier glacier in some hundreds of years, probably 200 or so, or else into the sea at the foot of the barrier if the ice melts from underneath.
This is because while the Ross Ice Shelf feels permanent, it's just not. It's always flowing. Here's Daniel Price again.
And then this ice is lost either by calving at the edge of the ice shelves, where icebergs break off, or by basal melting from underneath. And these are the two processes we're really interested in monitoring, because Antarctica and other ice sheets and glaciers, their presence is all dictated by what's called mass balance. So the amount of essentially snow coming in, and then the amount of ice leaving at the peripheries by melting or calving. This is what dictates whether it's in a negative, so loss, or positive gain, mass balance. And this is the key thing to the global community, because if it's in a negative mass balance, sea level is rising.
Ice shelves don't contribute directly to sea level rise when they melt because they're already floating in water. But they buttress the glaciers and ice sheets behind them. And there's a lot of ice in Antarctica.
Going back to that word colossal, it holds about 65 meters of sea level equivalent. So that were to all to melt, ocean levels would rise by that much. No one's saying that's going to happen in the short term, but even a meter of sea level rise is a big problem for society. So that's why all this science is being done down here, to try and constrain the numbers around sea level and understand how fast it's going to rise.
But there's a third kind of ice, the star of our series. Ice that does some buttressing itself, forming a band around the ice shelves in the wintertime. It's time to introduce you to sea ice.
So once we get to the periphery of the ice shelves there, we reach the open ocean, and the sea ice grows during the winter. The temperatures drop so far over the Southern Ocean that the water freezes. So this is the key difference between ice sheet and ice shelf and sea ice, is that the sea ice is frozen seawater. And there are many interactions between the continental ice, so the grounded ice and the ice shelves, and the sea ice, that all play into some of these positive and negative feedbacks that are very complicated to understand in the Southern Ocean. And that's another major part of research in Antarctica, is trying to understand the interaction between the two, and also to understand the changes to the sea ice regime.
The annual freezing and melting, the expansion and contraction of sea ice, has been described by some as Antarctica's heartbeat. And through its impacts on the Southern Ocean, this pulse is felt across the globe.
I'm standing on 2 meters of ice, and under that is the ocean. It goes off and connects the whole planet. So it's kind of mind-blowing.
Next time on Voice of the Sea Ice, we learn about the importance of this beating heart and meet some of the researchers helping us understand the role it plays in our lives. Thanks to Dr. Daniel Price of the University of Canterbury and Kea Aerospace. Reporting for the series was supported by Antarctica New Zealand, with special thanks to Megan Nichol for her help on the ice, and to Anthony Powell for audio recordings. Production help was from Ellen Rikers, editing by William Ray, sound design and engineering by William Saunders, with additional sound design by Steve Burridge. Thanks to Nat Taunga Sound and Vision for RNZ archival audio used in this episode. This episode also includes some sound effects from the BBC Sound Effect Library. You can learn more about Daniel's crazy traverse journey, including mind-blowing video footage, at rnz.co.nz/OCW. Tēnā koe I whakarongo mai. Thanks so much for listening. I'm Claire Kincannon. Have a great week. Kia pai te wiki.